just a few more minutes, just 2 more minutes again, and then we'll start on the dot. Alright guys, good afternoon. So this is welcome to lab 3.1 IPv6 configuration. So this will be used for the assignment 1. I posted assignment 1 yesterday, last night. Official release day is today. I'll send out a notice later tonight saying that the assignment 1 has been released. The due date is 3 weeks from now, Monday, 3 weeks from now, midnight. Right, of course, normal things. I don't worry about late. I don't penalize late submissions. You can submit late, but as I said in all my courses, if you submit in later, you're going to eat away into the other times, and it has happened with other group projects, people group projects, students group projects. Some say yes, you get extension, you're going to spend more time on it, but you're going to eat away in the time that you'll be using for something else. And sometimes some people work on it last minute, and the other group, my message group finish, and then this is not completed yet, right? So as much as I give that kind of flexibility, don't take too much of it, or let's say abuse it, the flexibility, because it's going to be negative in your outcome, right? All right, so this lab, that's one. Next item, lab. There's a lab 2.3. I kind of posted up. That is for PPP authentication. You can take a look at it. It doesn't have it has the PowerPoint procedures. You can follow that. We have debug and debug. So this is based on the lecture slides from last week. So you use the PPP labs for the authentication. In addition to that, that will be asked for in the group project. So you might get examined on it in lab exam, but you will be examined that you have to get it done in the group project. So regardless if you're doing it now or in the group project, you'll have to learn PPP authentication, PAP and chat. Right, so we're going to start with lab 3.1. This is basic IPv6 configuration. It's simple, and then we go on to the next lab 3.2, which will be a little more IPv6 stuff, and we'll work here. Now, this one, we're going to be basing it just online, stuff online. So if we continue, download the packet tracer file. What we're going to do, we're going to use the website, right, to get the information. Now, I also downloaded the files for that website, the web page, and place it online. So if you can't, you don't have access to the website, or the website doesn't exist anymore, I have the pages saved for that purpose. Alright, so this is the network layout, and at this point I'll stick here and then I'll open up the website page. Let's see if I can get the page open. Right, let's check that up here. Bad thing about this, it's good enough. Right, the bad thing about this is that the brightness on this projector is a different projector in lab, so brightness that you've seen on the Zoom video is not so good. Right, so you'll have to rely on the your shared screen from both Zoom and right, to get the brightness and the level of detail you want. Alright, I'm gonna just post back up the link for the Zoom stream so you guys can take it out, share it on WhatsApp. Right, so I'm basically following this and then building out the lab as it is there. Right, so you have some questions, any questions looking at this here. Enable IPv6 globally, you have IPv6 interface, EUI 64, global unicast, manual unicast, the ping, manual link local address, auto address, and then enable DHC verification commands. So we may or may not go this far, but we'll see how we reach in this lab. Right, so you guys could read out ahead. This was posted already, so you have read it. Right, we're gonna follow this outline here. Globally, this one a lot of people actually forget to sometimes they fail to do or unable to do, and then when they trying to enable IPs or try to view it, nothing is there. It's only showing v4 stuff, and you have to know why. That's because you didn't enable IPv6 globally. Also, this IPv6 globally also allows you to do unicast routing as well. We'll deal with that later on. I think, yeah, the assignment 1 will be doing IPv6 unicast routing, which is part of it. Right, enable IPv6 on the interface, EUI global unicast, manual global unicast address. So there's two types. We do the lab first, and the theory is on Wednesday. So when you go to theory, it'll be a lot of familiar stuff because I would have mentioned the lab. But the good thing, at least it'll be familiar, and then you could actually go back, read one, and come back in the lab. So that's kind of like both ways. The lab is not like throwing you out into the deep end. You have no idea what you're doing. That's why I like the body's labs. It's very detailed. Well, at least even this one, these people have. Manual global unicast, which we'll deal with. Then you do IPv6 ping, manual link local address configuration. We'll see that. Then auto IPv6. These three here basically generate a kind of automatic IPv6 address for an interface. The first one is link local. The other one is IPv6 auto configuration. It's also like a link local. And then you actually have base IPv6 client, which is actually leasing out IPv6 addresses to the clients. Right, so what we're looking at, right, enable IPv6, look what's happening, IPvcast, unicast routing. That's basically what it is. Right, that's enable IPv6, but you'll ask if it's a router, yes, this is important. If it's a switch, why you need it is sometimes you need this because the switch is kind of like a router where it has the management interface, can work like a router there. So you can set up stuff that works with the management interface and get traffic out. Right, so that's why you'll still need to do that on a switch. And you can see the commands here, so let's get started on the commands. I just need to get the packet tracer across. CLI, oh, the CLI is good. You see this level. Does it make a difference? I did bump up the font here. What happened? The resolution increased now to 1080p because I did it for projectors. So I said let me use it one time. and that's how you see my face on the video taking up a piece of the screen now. Right, so we have our packet tracer. First things first, router 1 and router 2, so we repeat the process on both routers. So let's get to the routers. Right, so router 1. I need to get the CLI up really large now. IPv6 unicast routing. If you press anything after that, there's nothing else after that, and we repeat the same thing router 2. It's simple. You do IPv6 and you do a question mark at the end, will give you a list of options. So we will look at unicast routing. Alright, that's it, enable. Right, so now we're looking at enable IPv6 on the interface. We should enable v6 on the interface. So this way we can use IPv6 enable command. So we're just looking at two interfaces on each of the routers, right? One's going in and out, right? Alright, these two, FS0 and FS01. So let's take a look at it. Put this to this side. And we could put this side. Next. Right, we're in router 1. Right, IP, and if you do a question mark IPv6, and you have an option, supposed to have enabled somewhere there. No shot. Right. And we select the next interface, Ethernet 01. Shut, right, repeat the same process in the other router, router 2. Right, and that's a good thing about most of these configurations. You know, there's just literally you could copy the commands, paste it for the other router, and just copy paste it, and that's it. It'll work. Let me see if I have my command file here. Do I have it? No, I don't have the command file. So if I had the command file created, I could have just copied it from the command file and pasted it into the packet tracer, and it'll execute the commands, and it literally didn't have to change interface. So let's go continue. Right, interface fast Ethernet 0/0 IPv6 enable. Now before I press enter, the no shutdown, I just want to go back to packet tracer. Right, so I'll just bring this up. So you'll notice one thing is that the interfaces, FA0, which is the two pointing, the two interface between the two routers there's two links, they're still red. Now I did a no shut on the router 1, both interfaces, but it's still red. Right, so that's, remember we did that with point-to-point links, right? And Ethernet links, same kind of thing. If you if the other link is down, you're going to still have a down link, right? If you do a show IP interface brief or show interface status. But if I do a no shutdown on the other side, the other link is going to be in up state. Is that once that happens, then it's going to have communication around. Signal is going to pass, and then it's going to start layer 1 communications and layer 2 communications, right? So if I do a no shutdown, and the reason I did that, no shutdown, the line link is state up, right? So this is something for you guys to use to remember that sometimes when a link is down because on the other side, and that's what I showed in the serial lab with the serial connections, right? So this is one, and then we could do the interface 01 IPv6 enable, and no shut should bring it up as well. So there you go, we got the other one. Right, this right, good. Just make sure I get right, good. Right, configure EUI64 global unicast address. It's a specific format that have talked about before. Well, what we'll be talking about in the class. Interface is created with the help of the MAC address. After that, this created interface is appended to the network ID. Right. So what we're going to do is that we're going to do a combination of configurations of IPv6 addresses on this. So some of it is going to be EI64, others will be automatic, some will be linked local and stuff. So we might be configuring all interfaces with this, but we'll see. Right, so we're going to use, this is the command we're going to use, IPv6 address. Right, IPv6 address prefix length command. Here IPv6 address and prefix length are the following. So this is it here, 2001 AABVCC. So :/64, and then EUI64. So what's happening is that this is the network prefix, and then the EUI64 will then build out the rest of it, and then create a running number as well to the V6 address. Right, now this is the next thing, because it's a /64, and that's the thing you want to do it, is that the 2001 everything up to C : once you have everybody has that same address, they're all in the same broadcast domain, if you want to call it that, right, in terms of IPv6. So whatever comes after that, it doesn't really matter. They're all going to communicate one another once in the same broadcast domain. Now, and once you know that, and that's where the assignment 1 comes in, we're going a little more detail. We're going to be using a /AT prefix instead of a 64. And we're not doing EUI64, because if we're doing a /AT prefix, the EUI64 would not work because it's a large amount. Remember, it's using MAC address to generate part of the IPv6 and there's a lot of bits. And it will take up some of that after the 64. So that AT is going to prevent you from doing that. So we're not going that way. Well, that's for the assignment. Right, you real with this MAC address after configuration. Let's see command here. So who are we? Router. So they're in router 1. So let's go to router 1. So if you're not so sure about the interface, just always do the interface and move to the next one, right? If you're not so sure which contacts you are in the interface, so you always type it back in just in case. Right, IPv6 address, and now they give you a whole lot of options here. And what we're looking at the third item there, the prefix. So I'm actually literally going to copy and paste up to here, and we'll see what options we have in there, right? Copy, paste, space, question mark, and now we're given some other options here. We have ENICAS and EUI64 is the other one. All we get is press enter, and we'll throw an error saying, hey, you know, scan start 0 or something like that, but we might continue. So let's do EUI tab 64, fill it out. Question mark after that, there's nothing else in parameters, so we just go ahead and press enter. That should not be nothing to it, sorry. Right. Right, we're done with this one. So N, take you back to the beginning. So let's check the IP address. Let's create to the command with the show IPv6 interface brief command. And let's do that. Show IPv6. Right, so remember we typed in 2001 ABC, there it is here. And now we have this other value here. Right, 260.47FF C801. Now it uses the MAC address. Now of course based on in this lab, because the equipment has a different MAC address than what they have up online or whatever they use, it will be different. The MAC address is different. One way you could really figure out is to actually force the MAC address to be similar to what they are using. Right. One thing you'll notice here is also a link local IPv6 address. We'll talk about that in this and later. Right. So in this case, this is their IPv6 address with the EUIC4 MAC address built into it. Right. So that's one. Now we're going to configure on the other side. So this is router 2. Interface fast on a 00, so we're going to configure the other side, and once that happens, we're going to test connectivity, right? So we're going to shoot the router 2. There we go. If you're not so sure which interface it is, type over the command. Right, so at least you'll change the context. Again, quick tip, if you want to know if you're in the right interface, you could always do a description, change the name, type description, and then test interface test 1, and then you view the running config and see which one has in description. Then you know that that's the interface you were in. Right, and when you're done, you can always change back or remove description, no description. Right, so we did the interface 0. Okay. Right, I'm just copying it here. Before I continue this, right, so what we're doing here, we're still doing this prefix part here, but it's a /64. But even though it's a /64, you'll notice one thing: the last few 1, 2, 3, 4 hex stats are numbers, so it's not, you're not leaving a double colon /64. It's actually a full IP address. So I paste this here. Right, enter. Right, no errors here. We could do an N. Right, IPv6 interface brief, and there it is here. This has been entered. Now the thing about it is that if it's done right, it's going to be an interface. This will help you out with your assignments. You test it out, you test it to use it. If it's entered correctly, it will see there. This will very help you with your lab exam, because if you need to enter it and you enter in, sometimes it might throw an error, but it doesn't save the settings because it could be incorrect. Viewing it in this show, we use the show commands to see what actually has been changed. That's a good way to test this out. Right, so we finish unit. Next step. Right, show IPv6 interface brief, which is what we just ran, and there's a command. Now, of course, because we put the actual IPv6 what they had used, and not based on anything dynamic like a MAC address, it's going to be the exact IPv6 address, which is good. You know, something link local value is different. This FE80, right? This is also based on the MAC address to that point. Right, now we're looking at IPv6 ping to verify that the link is up, there's connectivity. Right, you have ping IPv6. Now, the ping command in Windows, or at least from Windows maybe 7 and 10 and up, 8, 7, and 10, is that when you do a ping command, you can actually do a -4 or -6 to determine what IP protocol to use, V4 or V6. Right, while in this case they're using ping IPv6 to tell you instead of guys like the -6 in the ping command in Windows. Actually, let me see. Let me try terminal. Where is it? -4 and -6. Using any terminal IPv6. You think using v4 or using v6. Right now, the interesting thing about it is that if you're doing like a DNS name resolution, you're paying a host name or online website, and you have IPv6 routing through all the way down through your host, to your firewall, out to the internet. The ISP has one. Digicel is a good example. If you do that, you might actually get an IPv6 address of that address that you're pinging. Right, so that's the cool thing about it. And guess what? It's good when you ping it normally, it will happen. But sometimes you don't want the IPv6 address, you want the v4, and that's why you put the -v4 to force it to give you back the v4 address to ping. Right, so that's why that's why they have that parameter there. And that's the thing. It's once v6 is and routing is working, it's going to, and you ping it, it's going to, the DNS is going to result to v6, because that's where everybody wants to go that way. The world is platforms, everything wants to go towards IPv6 as a default layer 3 routing protocol. Right, so that you use that and try to move away from v4, which is going to take a really long time. Right, so let's move on. So now we're going to do ping command. Right, so this is in this case in router 1. You'll notice where it is. Router 1, we're going to ping this full IPv6 address using the ping IPv6. So let's go router 1. It's right here. Right. Right, so we're getting something. Success is 100%, which is what we want. 5 out of 5 pings. Round trip is negligible because it's literally directly going through the router. There's no hops to deal with, so no delay. In the if it's a fiber line or something, you will get a few milliseconds, 1 or 2 or something like that. Alright, see this guy actually have 001. We have 000 milliseconds because software. Directly and connecting software. Right, to check the configured address, you can do show IPv6 interface, and you should get the information. Check this out. Come on. Piece that out. Right, this is 00, so it's EUI64, right? That's what this is, right? Right, that's it here. Right, repeat the process on router 2. Let's go back there. Right, so one of them is the EUI64, while the other one is a regular link local address. Or unique local address, sorry. Right, different things with ping IPv6, you could do other commands in here. So just come back here. Right. Unfortunately, the packet tracer has this option. Maybe GNS3 might give you more options to do a ping. Right. So if I do the question mark, normally it's supposed to do it. Now if I do a ping IP, right? If I do a ping IP, Let's see. No, it seems to be the packet tracer versions or the Cisco routers that you're working on. If you do this in GNS3 and you do the ping IP or IPv6 and you do a question mark, it's supposed to ping up, pull up a lot of different options there. So GNS3 might get it, not in the packet tracer. Right, so that is the difference again. GNS3 have some advantages over packet tracer there because it's actually using real iOS. Packet tracer is a kind of custom iOS kind of thing. I don't remember to get a. Wait, I think I do have one. Alright, just bear with me. Let's fall. It might fall in now. Unless I stick it up on the ground. It might fall. It might fall. It will fall. And it's just gonna tune now. Do have magnet here. Alright, never mind. Alright, I'll just do it. Might fall. Alright, let me just leave that. Sorry, the camera. Okay, this might fall. Yeah, it's gonna fall. We'll see. It'll be fun. Alright. So they put some options here. They can ping, they can change the repeat and the source and all that. So we can't do that in this packet tracer lab so much. But you could do it in the GNS3. So if you want, you guys could take this option and repeat that into GNS3 if you want. Right, now we have something called the manual link local address. So we just did a ping router to router, IP ping to ping. Those two interfaces are good. If I go back packet tracer file, you can see they're working. Now we're going to have to do the other two interfaces, FE01. And in those interfaces, we're actually going to have the different methods, right? You have manual link local address. Right? So we're going to configure gig. Why are you doing gig? We'll do gig. The gig is, let me show you what gig is. Gig 01. Who's gig? Right? There's no gig here. To make a typo. Right, we're going to configure the fastest interface of router 1. Wait, did I use? Hold on, let me see. Hold on, let me just check something now. Nah, yeah, they typo it. If they were using FastNet before, then the fact that they're using gig now means that they typo it. That's not correct. There's no gig in there to use. Alright, that's fine. So we'll pick this up and we'll see. So we're going to configure FastNet 01 interface of router 1 with the link local address. Right, there's no need to write a prefix length, but we'll add the link local keyword at the end of the command. So we're going to see the example here. Right, link local. So let's get into that. Router 1. /1, right? I'm just gonna copy that whole thing here. Right, before I do link local, I can actually backspace and look at that, they have the link local option here. Right, space, question mark, nothing after that, so that's it. Link local, enter. end. Right, as usual, we check in again, show IPv6 interface brief. Fastnet 01, this is what this guy is. We just did the make sure CCDD, right? Scroll down there, look in there. See, look at that. You say gigabit Ethernet, but it's still fast Ethernet. So again, there's a typo in there, and that's okay. Right, and now the next side we're going to use auto IPv6 configuration. On router 2 on the fast Ethernet, again the typo it again, gigabits, right? So we're going to use interface fast Ethernet and IP address auto configure, and we're going to see what's happening there, right? So router 2. Right, so we go ping there, we get sprinted. Interface fast Ethernet 0/1. IPv6 question mark, and we have some options here. Address. Right, in this course we might just do a few of these things. Address, DHCP, might do the enable and stuff, but things like NAT, OSPF, RIP, summary address, traffic filter, and all those things, we would not be doing that in this course. Right, IPv6 address, question mark, and we have them options. We did the first one, we kind of did the second one. Now we're doing auto config. Right, let that run, and then DSP is the other one that will follow. Right, and show IPv6 interface brief. Right, so here it is here. I think there's a chance it already did it before. So let me just go back up. Yeah, look at it, it's already did, nothing changed. It already did the auto config, the FEET. Alright, let's go down, let's check and see what they're saying. Yeah, see, FEET. Of course, the interface, you'll notice a few things on the output. You'll notice the interface is in an up-down state, while ours is in an up-up state. Right, so it depends on what configured here. So something is way there. This is an up-up state. So something is weird here. Maybe the output wrong or what, but that's something for you to look at and investigate why. And there's other additional information you can use in your network and explore. Right, so ping router 2 to router 1 to test the second IPv6 interface. So we just copy this command. This is in router 2, so we just do that thing. Simple, we're just pinging its own FEET. Output interface. Alright, sorry, that's spelled out right. Right. Main reason why it's doing that is because it's identifying two interfaces that are in the same subnet. There's a /64s, and one is our FEAT slash big number slash 8, I think, and the other one is a /64. And technically, the 64 should be able to ping that one too, so you'll know which one. Right. I know technical two is different subnets. When we break it out, you'll see the subnets are different. Right. So there we go, success rate. Now if you do the ping command again, and let's say fast Ethernet 0/0, it shouldn't work. Right, because those two interfaces we configured earlier are /64s, right, and we are trying to ping a /16, but it's a totally different. If you look at the first octets, we're pinging a FE80, right? As a double colon, which doesn't even match our 2001. It's totally different bits matching, right? So therefore, it's not going to work when you do that interface, right? So at the end of the day, it will not be the correct interface. So they're literally different IPv6 subnets. So we just got a success before. Right, so now to enable IPv6 DHCP client function. Now we've done it and we already configured 4 interfaces with the different methods, and now we can look at the IPv6 client. Right, it gets from a DHCP server. So let's enable a DHCP v6 on, well, not Gigabit Ethernet 2 router 2, so it'll have to be fast Ethernet. Wow, they really, or no, this. So it's not Gigabit Ethernet 02, it's fast Ethernet 01. So sometimes you have to look at the commands and make sure that they're doing the right thing. And again, you look at the equipment, right? Show this is status, and status doesn't work. Alright, so let's do show IP interface, right? And we could do, I see no IPv4, so we do show IPv6. Right, as you can see, there's no gigabit 0/2 on the router. Again, the closest is either and there's not even a fast Ethernet 0/2 either. Right, but of course, based on what they did, it's fast Ethernet 01, so you follow that. Fast Ethernet 0/1, IPv6 address, and a DHCP. Right, so now we finally configured, right, and we can do a show IPv6. Well, it's still showing this, but we'll see how to fix this. Right, let's follow what they're saying here. Right, so what we just did here is that we showed that, hey, we did the IPv6 interface brief. We've gone back and checked this at fast Ethernet 01, but it's looking like the link local is still there, nothing new. Ideally, a DHCP interface IPv6 address would be something like this, so this form 2001 or something like that, 2002. Right, so it should have been in that form if that's the case. And it should have two. You'll notice that fast Ethernet 00 has two IPv6 addresses, right? A link local and the actual unicast, global unicast. So there's two of them. DHCP is supposed to allow you to assign a global unicast if you need to, not just a link local. So what's happening? It's not happening here. But the good thing is that you say once in a while, how can you tell the interface is enabled or not? You can do the show DHCP interface, and it'll tell you which one is in client mode. Right, and it's status solicit. So this way it's asking for. So this is like a request. So this is the thing with IPv6, and when we do that later on, hopefully we'll do that when we do that Wednesday if we cover it. But the slides will have it, or if I don't cover it, slides have it. The mechanism of which IPv6 gets and whereas client gets IPv6 addresses is using something called solicit message, and then you have responses and stuff. So it's different from the terminology is different. In regular IPv4 DHCP, where you have broadcast request and acknowledgement and response. So this time they change over the term solicit. Plus the mechanism slightly different, and that's why they change that and use a different term. Right, when transmit expires in 3 seconds, rapid commit disable. Let's do it next. So let's do it again. So you see time expires in 2 minutes, 6 seconds, right? Again, still didn't get our IPv6 address via DHCP. Right? You can do show IPv6 interface. So this is on router 2. Let's go to router 1. Let's try this out. Right, and 0/1. And give me the details, right? You have global unicast. Let me see. think that's 00. Let's go back 00. Here. You have the EUI 64 as well. IPv6 neighbor caches. We do a show. Right, so this is cool because it picks up the v6 address that is on the interface cache. I think. Hold on, let me see. No, it's router 1. Yeah, 1 to right. So it's actually picking up the IPv6 address that it learned from the neighbor itself, and this is how IPv6 works. So maybe even if you don't ping, it will pick it up by what you call router advertisements or different IPv6 advertisements going across the link. So it actually picks it up, so you don't have to work. From here, you can know who is the client on the other side. So it's a good way of identifying if a client is able to communicate with you with IPv6 by using this mechanism. Right, I'm going to do the show IPv6 route. Right, so I have not done IPv6 routing or thought about routing overall. Now they have when you do the group project, you guys will be learning about v4 routing. So the group project is v4, not v6. So v6 might be all the way up to the assignment, and I wouldn't be dealing with more detailed v6 stuff later on in the course, right? So once you reach up to there, you're fine with the v6, you're good. Routing will focus on IPv4 BGP, not to complicate matters. And so here we'll do some IPv6 routing and see how it goes. And this will help you with your the assignment. Right, so we check the routing table. Right, so a little thing, as again, I did not do any routing in the labs. All I just did was just static IP addresses. I did do IP routing, yes, in lab 2 last week. When I do the show IP route through interfaces, you would have seen some RIP or SPF stuff, and I did some very kind of detailed explanations about it, where they actually advertise in the routing table. You have directly connected as well, so all that was IPv4. v6 is similar, so you have things like directly connected here. Because it's directly connected and it's an up state, if I have to shut down this interface, it would not be in a directly connected. Right, and not only that, they have the actual IPv6 address here, local, and then again you'll have a link local IPv6 address here. Right, let's see what here, local, right. Right, so this is the network connected, network that it knows, and then this is the v6, actual v6 address. You'll notice the /128 means it's all bits, that's the actual IPv6 address. And you see same thing in the when you do IPv4 route or IP route, you'll see the /32 to know that is the actual IPv4 address on that interface. Right, going through some here. Right, you could do a true IPv6 DHCP. But before that, let me just go to router 2 and repeat the same process, right? Right, again, they have their IPv6 address, its own, look at this one connected. So you'll notice between router 1 and router 2, they have the same network here. Yep, sorry. All that one. Right, this router 2 is supposed to be the same. Right, so in router 2, let's do show IPv6 protocols. No, sorry. DHCP. Right, this DHCP unique identifier is this. This is supposed to be matching up a MAC address here. Let me see there. 123, 123, 123. Should be here. 047 B7C 801. Right, so this will be six pairs here. 1, 2, 3, 4, 5, 6, 7. No, no. No, it's not 6. Okay, hold on. I think it's up to here. That'll be the MAC address. Right, let's go back to router 2. Be the same process. What's going on now? IPv6. Right, so its own unique ID is different as well. IPv6 protocols connected. The routing protocol is static. Nothing too fancy here. We're not worrying about that. What's going on? Right, no problems there. Static, right? I think that's it. We have some FAQs here for the these are FAQs. You guys could go through it and read up just to get an idea of what they are. IPv6, you can check the answers. Some might go up, some might be any CCNA questions and stuff like that, or any quiz, any coursework exam one. Right, so let's take a end here for this lab. I'll take a break now. We'll take a 10-minute break. We'll resume at 7, and we'll continue lab from there. All right, so let me just put that in. 10-minute break. Just mute and keep up my video. guys, and we're back. And then across. Cool, so that ends on this lab. Let's close this off. Save this. Right, this lab wasn't doing all the other stuff, we're not doing that, so we just focus on these here. Right. And that's repeat that, and this out, and this one. Right, lab 3.2, and same as before, as we're going to look at another lab. Now this one is actually the packet tracer, an actual packet tracer activity lab. So I'll bring that up. That's why I brought both of them, because we're going to see how the activity itself, how they do it. All right, as you know, with the activity, when you open up the file, we get to it. Let me just close the first one here. I don't need this. Right, and with this activity file, you also have this document here in the activity as well. And in addition to that, well, I would have saved the pages. So that would have been IT exams online. That's this file. That's this one here. Right, actually no, let me switch this to the left. A little more detail on this one. Right, it's much more network. So, and this is where you might have the routing as well. Address on the router, servers, clients, networking connectivities. This is the next step where it's going to help you out in the assignment 1. Right, enable router forward IP packets, which we already did, so we're going to do R1. Click on that. CLI, hold on, let me change this font size. $14, $12. So it goes now. Alright, cool. Alright, enable, configure terminal, IPv6, unicast routing, it's enabled there. Well, to give you some steps here, and the command to transition interface. Right, now we didn't do IPv6 enable, but sometimes if you do it, it should enable it. Once you do the entity address, it should enable. So let's try it out, right? So we do an interface. Again, internet 0/0. You could do a do show IPv6 just to see what's already configured. As you can see, nothing is assigned. So we can sometimes you should do a pre, and I didn't put that in this case, but they should have done it too. Sometimes you do a pre-check on all their systems, and that's why for me with the Huawei Cisco commands and Huawei command, I have a whole lot of command sets with the show commands. You'd have seen it in put it on my learning. So I'm actually use that in an environment. So if I want to do a dump of all the configuration of equipment and know what's running in it, not just the running config, I will have my whole list of commands. Just copy paste that terminal length 0 in Cisco, just paste and leave it. Let it log to a log file. Should anything happen, I have that file I can use back now and see what's the status of this equipment. So it's very good for when you do any offline, any forms of offline configurations or checks, and it does come in handy as well. So use that. So this is that method and the commands. Use that when you're in your network career when you're doing these configurations. Not just with Cisco, with Huawei. Huawei has a little caveat. Some equipment don't allow it. It doesn't have the, with Cisco of terminal length 0, so at the end of the page, you normally just press spacebar, enter to move to the next page. Right, with terminal length 0 in Cisco, it tells it, okay, forget that, just keep outputting to the screen. Don't wait for any prompts to say press any key to continue. Just keep outputting. Good thing is everything goes to one screen in non-interactive, so it doesn't need your input. But negative about it is that if it's dumping some large amount of information, you cannot stop that. Cannot break out it, no Shift F6 cannot. Control Shift 6 would not work either. What you might have to do is close the terminal, and worst case, if you close the terminal and open it back up, it's still going to output to the console, continue outputting. So that's a bad thing about it, but you have to know what it is you're writing in. As opposed to Huawei now, when it reaches a point and it reaches a screen, next screen, you have to press any key. There's no bypass around it. There's certain Huawei equipment do have a bypass, we say no end of line, or tell it not to use an end of line, and they continue. But more modern Huawei equipment will have that. Older ones don't. So I just a little stuff there telling you where you can collect information. So like show IPv6 interface brief. That's telling me what it is. So now we already set the interface, and we can just copy paste. Alright, I'm going to type out the whole thing and enter. And we're going to do the link local as well. Before that happens, let's do a do show IPv6 interface, and look, it's there, enter. You notice how we didn't have to do IPv6 enable, right? Right, we didn't have to do it. Right, it's already enabled once you start entering the address. So sometimes like that, or you have to do that. But sometimes you may have to remember that, because the Cisco exam may come with that and say, how do you enable IPv6 on an interface? And then it will give you the list, and IPv6 enable is one of them. Alright, let's paste this here. Link local. And there it is. So now we're going to do gigabit Ethernet 01, and this is on the router 1, right? Go back, make sure, right? Just make sure what context you're in. Because the only no way you can tell you in the router 1 is through this prompt to see, and in your prompt as well, matching up. If it doesn't, they didn't have a prompt here, right? Right, so gig interface, right? Right, so you see, look at that. Enter the commands necessary to transition to interface configuration mode for gigabit Ethernet 01. Well, I just put the command there, interface gigabit and 01, but sometimes you may not want to waste time trying to figure it out. You want the command to just type. Sometimes what we call blindly type, the blind steps, right? So, but this is more for you to start thinking what it is you need to do and all that. Refer to the addressing table to obtain the correct IPv6 address. Look at that, the say configure link local and activate the interface. Again, they oh, I forget to do no shot. Let's see, this is activate, right? So look what happened here. They tell us activate, I totally missed that step. Right? What do I mean by activate? No shot, right? Because look, I made sure to leave down, down. So let's go back to the interface. 0/0, and we're gonna do let's do a shot, no shot. Change to up. 0/1. IPv6 interface brief, right? So he is in a up state, which is what we want. Good. Right. So in this case, we want to repeat the process. Over the same, and the same link local as well, right? The link local is easy, so you can do an FE EAT ::1 link local. It should work. Right here, I said, well, why will the same one will work? And we could use the table to show. Right, so let's scroll up on this table here. Right, link local FE80 ::1. So some ask, well, how in the world am I able to have multiple interfaces with the same link local IPv6 address? And I'll get to that just now. I'm going to finish this IPv6 address here. Right, copy him. Right, that's what we are here. We'll repeat the process. Right, run the history of commands. Now to type it out manually. Did I say? No. Right, db8 1:2:1/64. Right, so notice one thing. When we go deal with this on Wednesday, you see where that double colon is. In most cases, that's where your boundary is. You have all the zeros. And bitwise, if you checked it out, 64 is supposed to be the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 hex stats. You're not seeing these. There's supposed to be leading zeros between up before the ones and a leading zeros between the two to make up 4 hex stats in that hex values in between the colons. Right, that'll make it 16, and 16 by 4 will give us 64. Right, 64 bits. So that's the boundary here. So once this one is a :2 here in the boundary, even though everything else is the same, while the other one before is a :1, which makes these two on two different broadcast domains, even though on the same, this different interfaces, different broadcast domains, different subnets, means that they're going to have conflicts going on to send information. So that's fine. Let's go and enter this thing. I think I did the link local as well, so I do show IPv6 in brief. Oh, I didn't. Right, so there it is, the one I wanted. Of course, it's down, so we have to do a shot, no shot. Should bring up there. There we go. Right, this is up state. This is what we want. While we're here, we don't end. Oh no, they say they have one more step here. Configure the v6 address and on serial 000. Transition to serial. Get the IPv6 address. You also have the link local address. So you'll see some things kind of shortcut in here. So we could copy the serial IPv6 address. For this serial 0/0. Missing one there, right? You notice, and this is the interesting thing. So even with the steps, they say, hey, configure the IPv6 on the interfaces. You can, once you have this table here, and they say just configure everything, IPv6. Once you know how to know the commands, the information is there in this table for you. So that's how easy it is. That's why I'm saying, document your stuff. That's why I'm expecting you to have for the assignment 1. I expected that documentation in the document, and I'm stating it in the assignment. Right? That's for marks. And the commands using, that's for marks. You must submit that. The file too. This table will help you rebuild whatever it is you need in your network. Right? So right now, let's say your network is totally 0, 0. You take your PCs, plug them together, connect them. Your interfaces are done correctly. Well, they're showing nicks in this case here, but the interfaces are done correctly, connected right interfaces. What you're missing now is the actual layer 3 stuff, which is the IPv6 layer 3. And that's this table here. Look how easy it is. So interface serial, I come back in here, IPv6 address, and I paste in here. Ooh, and it automatically entered it for me. Unfortunately, I end up, and that's the next thing, the double click and copy, it actually picked up all the new lines and card returns and stuff, so it kind of messed it up. I don't like that, but that's how it is. So all the extra special characters here, it picked it up at the end here, and then that's how you get the extra enter. So it executed one time. Be very careful with the copy paste then. Sometimes it executes one time. So for me, if you're not so sure, that's why I copy it into a text file first, verify what it is. In fact, let me do that here. Heck, let me do that right now, since you guys may or may not watch this video, but at least those who are watching now will see what's happening, right? You get an idea. Create your command file. Right, so I could do 00/0. Look how easy it is. That's how it is. Look, I got my command here. IPv6 address. Right click and paste. That's not paste. Paste. Right, it pastes. Well, I don't have to paste any extra into it. Right, so just delete some extra. If you're not so sure, just delete any extra characters here and you press delete. There's nothing at the end. And then you type a 64 for you know that's for sure. Look at me, I already started my command file here. I could have done that in this lab. Come back in here, right click, paste. Command's already there. And I could even do a do show one time here. Do show IP. Right, so I just right click, copy. I could come back here, right click and paste. And boom, right there. Or be even better yet, I could just copy, highlight all these guys, copy, come back in here, and paste over the same commands. It's going to rerun it on the same interface, does not matter. Let's say you make a mistake and say, oh no, I make a mistake, this is not supposed to be 2, it's a 5. Change it. Now two things I could do. I can undo that information. There's a lot of hack tips I'm doing here, right? So you could have no command, doesn't have to be there, it could be the 2, and you're going to put the 5, right? So I could copy all of this, come back in here, right click and paste. Well, is it? Yeah, look at it, look 5 there. But the other one gone. It didn't show an error. No IPv6, it removed the interface. Now, you don't need to do the no if it's the exact same IPv6, but it's going to overwrite itself. It's going to overwrite. So I can actually remove the no. And this is a little tip you guys could do. I could put an exclamation. This is Cisco. Huawei does it as well. Put an exclamation and a space after it. Exclamation means more like a comment. I think the pound sign is also comment, the hashtag. So let's do it again. Copy. Come back here and paste. Look at it. No here, it didn't execute. No errors. You didn't have to remove it. And it overwritten. Okay, and if you don't believe me, let's do a number 6. Actually, let's go back to 2. Let's go back to what it was, right? Copy that. Come back in here. Paste that. We got some, look what's happening. So we got a 2 and a 5, right? We'll see how to fix that. So we got some errors here, right? Let's make sure it's errors, that error is there, right? So now we have 2 IPv6 addresses on that interface, supposed to be 8. Right, so we have some bugs happening here. We don't know if that is correct. That's supposed to happen, but we don't know what the double colon 5 is there. But let's, for the purposes of don't want it, let's take him out. Fix that out. Put a no here. Put that 5. Copy that. Paste. and now we're back to it is removed it, back to 2, we're done. Repeat this over and over, it would not make a difference. It will get back to the same result. And that's what I love about these Cisco commands. And if you make, look at how I went and made mistakes and then fixed that mistake. Right, so this is what we talk about of a rollback when you're doing what you call change management. You have a rollback commands. These are commands that you can write that'll do your rollback or undo the mistakes that you make. Right, so I'm just giving you a tip here. This is the command file that you're building. This is for what I expect for your assignment. For those who are doing well, not those, but I expect for the group project. For the lab exam, up to you to use a command file to fix your errors one time. Some people like to type straight into the console, and you're going away and you make a mistake, what's happening? Some actually create a command file. Now, for the lab exam, you're not required to submit a command file, no. You just save your configurations and you submit the package file. That's the lab exam. That's all, I'm marking that, right? So for there's some students who would like to use a command file, makes it easier for them. I do tell them, I say you don't need to submit that, I say no problem, that's making them do their stuff faster, the answers and stuff, and then they can see their mistakes very easy. Right? So that's what my tips are for you to do this. And guess what? This is going to work for you for your network career. Those who not going to go in network career, just do it for the just do it for the class and labs and the exams. Right? It'll help you out. Right, so we're going. So we just finished serial. Did we do the FE80? No, we didn't. So let's go into Google. Let's add it in here. Right, IPv6 address. Which was the link local? I can't remember what it was. Right, there it is. Copy this guy here. Paste him back here. I'll literally copy this whole thing and paste it, and then we'll get him back all link local. Right, link local is there. Something was up. Look what happened there. We didn't use the link local yet, but it changed. It was an automatic link local created, but now we forced it to a link local we want. Right, so it changed. Well, that's part of the lab. That's a requirement, that's fine. There we are. So look how easy it is to do this lab. I can create a command file there, right here and there. Right, so we finished this piece, and now we have to just activate the interface. Let's do a shot, no shot. Just to make sure, right, state, right, N. And of course, we can then write memory. I expect that's in the lab exam. Expect that in the assignment. Right, good. Configure IPv6 addressing on the servers. Alright, so before I continue, so you'll notice that the FE80 and all these interfaces here are the same, ::1. So the thing about is that why is this possible? Because FE80's link local is only between that interface on that device and the interface on the other side. That's it. That's the only time it needs to be unique. FE80 ::1 and FE80 ::2 on the other side. Right? And you'll notice that that is the case. If they did have it here, you'd have seen FE80 ::2 on this guy, :2 here, :2 all the way down here. Because let me see how the design looks like. Right. All these guys could be FE80 ::2 and it'll match up. Well, it would not be the same as FE ::1. So because it's localized, that's where the FE80 ::1. Well, you can see they're on a switch. They're all in the same broadcast domain. So therefore, it'll be ::1, ::2, ::3, ::4. Right? That is this broadcast domain. So because it's the same broadcast domain, they will be different. But because these interfaces are in different broadcast domains, they can actually afford to have the same link local. And it's only link local, you can do that too. You can have that, nothing else. Right, so we're going to servers. Right, so in accounting, click desktop IP configuration. Where is accounting? Accounting. Desktop IP configuration. Right, I just copy paste in. There it is. IPv6 address, right? Paste. 64. Right, they automatically set that to me, that's fine. set the gateway to FE80::1. Right, so what is it? Default gateway, there it is. Right, so this is one advantage of having the FE80::1 and all the interfaces that all these servers, regardless which interface you connect to, will use the same FE80::1. It'll work, it's localized and no problems. Right, so that's one advantage of IPv6. Now, that said, for my more or less the group assignment, when you're dealing with IPv6 addressing, I will not want you to use the default gateway as the FE80::1. I think you'll ask the question, I'll have to put the answer to that. No, you'll need to use the what is the global unicast IPv6 address as your default gateway, right? Because that's more, it's more the old school IPv4 stuff, but it's more a matter of that this is what you control, you configure, and you set it. In this way, it's it's there, but it's not like, okay, you know what really default, what your real gateway is. It's supposed to match up your IPv6 net subnet, right? Match up that, and that's what you want to use. So it should match. In this case, who's it? The server is at one of these, right? So this should match 114, right? That's the gig00 interface, right? So this is where your default gateway should have been this address. And that's what I will want in your assignment 1, that address, not the link local address. So questions will be asked, and that's the answer will be. Right, so that's the server we're done here. You can click any physical, it should be able to, once you tab or click away from a tab, it's supposed to be, it's supposed to save and not show an error. So we can close that off. Right, so we did the accounting. Right, repeat the steps, shortcut again. Find the really variables. On the CAD server, the CAD is all the way down here. Desktop IP configuration, and then it's the same thing. So IP address, default gateway. Right, so what it is, FE80::1. Makes life easy, yeah. Right, so let's see what's the v6 address for the CAD. That's this guy here, 2001 dB. Right, paste them in here, 64. Right, so this is the thing. So this is the scope package is not going to help you so much, is that the commands is not CLI, it's GUI. You have to go click, point and click to get this done. That's the only bad thing I don't like about it. Right, let's tab out just to make sure it's saved. It's saved, it's still here. The information incorrect. Close the stuff. Close the server. Alright, who's next? Right, so these two servers are now the clients. I'll be using FE80::1 because that's what we set. So that's fine, it will work. Sales and billing and design engineering. So basically these steps are just repeat. So let's do it. Sales and billing. You know, this is the configuration almost the same, because it's the same way. The difference between a server and a client, the server has like other application services providing services to clients, which would mean like an application running in the background as a service. Right, so let's go up to, and like I said, you build it from here, right? So sales, who sales this? So copy that, paste that there, got that 64. No link local, we leave that out. Default gateway, 80::1, right? And honestly, we'll see what happens when we come out of this. Desktop, it's locked. Let me save this before it crash. This is play. Always rename your file, package as a file. I call this play as part of playing it as I go along, as I rename it. Don't want to override the original. Right. Right. It generated a link local address. Look at that in sales, right? Look at that, FE80. it'll still be able to connect with FE80 or FE80, so it'll work. Right, good. Billing, laptop, desktop, IP configuration, copy the information here, copy, not IPv4, it's v6, it's all 64 bits, let's go with that. Colon 1, good, go back config, I'm just trying to put on this error, I don't know why I do that. Right, it's automatically generated its link local, that's fine. So we close this guy and we repeat the process. We go billing, who's the next one? Design and engineering, that's the other two. Desktop, IP config, copy that, paste that, 64. Use hotkeys, guys, use the hotkeys. Look at that one, default gateway, they have it there for you, right? Right, I'll go physical desktop, right? So it's safe there, we should be fine. And engineering. Desktop, IP config, engineering, that's this guy here, 2:3, copy that using shortcut keys now, 64, right, FE80:1, I'll just go back physical, get it back, right, excellent. So we've done all of this. And now we just do the simple. Open your web server, the server web pages from the clients. Web browser, and then you enter in this IPv6 address. DB8:1:4. So it's :1, right? :4. Actually, it's :4. It's an IP address static, right? So it's somewhere here. That's this guy here. Accounting is a web server. Service. That's what's happening here. That's fine. Right, so who is this? Nice. So we go on sales, we go in the desktop tab, we go in the web browser, waiting for this to load, we go in crash, getting us crash, hold on. Now it's back, okay, good. Now I'm going to paste this here, but it may not work. We'll see what happens. Right. Okay, it works. Now, typically, there's sometimes for IPv6 addresses, you put it in the square brackets, right? Not the round brackets. And that's how you enter IPv6 addresses itself in like Firefox and all these browsers. So this kind of didn't allow that. This allowed it regardless. Right, so when you're browsing sites with IPv6 addresses itself, you will have to put it in a square bracket. Now, that's assuming that your PC can ping an IPv6 address out on the internet. If not, well, square brackets ain't gonna help you. Because if it can't get an IP, you cannot ping, you cannot browse the other services. Right, so like I said, layer 3 pinging, ICMP pings, if that doesn't work, then you can't get the higher layers to work either. Well, unless there's ACLs involved, that's the next story. Right, so what it says is go into, right, so they said enter another one. So I'm going to clear this, square brackets, paste that, go CAD server, right, welcome to the CAD server. So to say, repeat it to the rest of the clients. As these are billing, right, web browser. Just wait for it to come up. It's taking a while. It doesn't crash. Right, good. Right. Paste that in there. Cancel, right? I'm not gonna repeat it for all of them, but just to tell you that it works, right? So we're basically able to access local server here, what we did, but the most important, we're able to access a server across the router. Of course, it's ping the IP address of the ISP, and the ISP is more or less the internet. If I click on this, it'll tell me locked. Very cool. Right, here it is. It's locked by the design or design, so you can't see what's behind any ISP. Right, this is really slowing down a bit. Let me save this just in case it crashes. Right, so open any client computer. So go back to building. Close the browser. Right, desktop command prompt, and do a ping command here. Oops. Kind of ping twice, right? I ping in there. Let me see if I can do a trace route. Right, so it's going to, and look at where it's going. It's going to the not the FE80 here. The default router, when you're doing a trace route, not the FE80, it's actually using the actual IPv6 address for that subnet. So that's the ::1, and not the FE80:1, right? And then it's the one hop to the router and hop to the ISP. So yeah, this is done, but you ask yourself, what's really happening in the background? Why are we doing that, right? So before we wrap up here, just maybe 5 minutes, we'll just go through a bit on the router, right? IPv6 route. Right, so all clients, because they configured as a route as a default gateway, the router knows all the networks directly connected to it. And in our case, luckily for us, everything here is everything that is what we're trying to ping is this router knows about it. So the knowledge of all the routes are in this router, which is good. For the assignment, the knowledge of the routers is beyond just one router. So you will have to add in some IPv6 route commands in there. I would have you read some material online and do that. So typically the lab itself is not going to do it because this assignment is take home, right? So you're going to have ask questions, forums there, that's what you're going to do. Right, there's labs again to help you get some experience and then go into the assignment. Once you finish IPv6 for the assignment, that's it. You cannot, and then you have multiple choice for the coursework exam. That's it. You're done with IPv6. It's not going to come into the group project so much. I don't think so. I'll tell you, and it shouldn't come in the lab exam. I will verify with that one too. Right, because I would have assessed you in the assignment, so I'm not going to reassess you again. You already know how to do it. That's why I did all that static routing in there. So you're going to do some IPv6 route. Let me show you config T, and then you're going to do IPv6 route, and it's going to be 2A network and via an X hop, and that's what we're going to do. So we're going to have those commands split up in the forum. Right, but as far as this is concerned, all the networks need to be known by each client. The router knows it, so it knows how to send it back. And everybody is setting the router as its default gateway, so when the packet has to come back, it's going to go back to the router. As a matter of fact, let's do, since we're here, let's see if I can get into the simulation mode. If not, well, I'll leave it like that. Perfect. So simulation mode is going to allow me to slowly trace where this packet is going and come back in, right? So I'm going to start the process. Right, so this is the packet that you're seeing here in billing. Going to the next step. All these are protocols here, but I'll leave them on. Shouldn't be a problem. Because it's spanning tree will be something you could deal with that. Right, so the packet goes to the switch. Switch should do is forwarding, it'll go to the router 1. Guess what? Router 1 is going to forward it to ISP. It knows that where it is. It's directly connected, that's why. Now the good thing about this is that it's actually let me see, cool. Guess what? The name is router 2. So you see, you have different ways you could find out what's in the back end. So what's really happening here is that they actually have a router 2 in the back end, as you can see, and it's actually going to respond. So if we go to the next step, router 2 is going to respond back. So technically that ISP is just one router device, and they just put a cloud in it. They group it in a cloud. It looks like a cloud. So they want to make it look like an internet cloud, and you could do that in packet trace. Just group a bunch of objects, make a cloud, and that's how it works. Right, and it's going to return, and that's it. That's it. Back to the PC, first response. Process will repeat itself until all the pings are done. Right, so you go back to real time. Right, so that's why I'm showing you. That's how that router knows about the direct connect, and then the ISP router 2 is saying, well, my default gateway is back to router 1, so it'll send everything back to there. Right, let's save one more time, and I think that's it. So that's the end of this session, and yeah, we finished kind of earlier. All right, guys. So I'll see you guys on Wednesday for our class, and after that will be next week. All right, bye everybody. See you on Wednesday. Is there anybody online? Yes, they are. Okay, good. Nice, good. Alright, I'm just going to stop share and then end the meeting. And then stop stream. This and the flag.